for mixed hybrid environments, we now offer a generic DNS controller, offering greater flexibility beyond just the standard bind in Microsoft environments. In that spirit, I would again like to welcome you to our newest webinar, the KNOT DNS Server. There was a time when Bind was the only open source DNS server available, but those times have changed. As Karsten Strotman from the Men&Mice professional services team is here to show you. Quick word on some housekeeping. If you have any questions during this webinar, please feel free to use the chat functionality. I'll be recording the questions as we go along, and then we'll have a Q&A session at the end. So without any further ado, I will hand off control to Karsten.
Yes, hello. Thank you, Paul. Hello, good morning, good afternoon. This is Karsten from the Men&Mice professional services team, and today I'm here to give you a little bit information on the KNOT DNS server. The KNOT DNS server is a relatively new authoritative-only DNS server that is produced by the good people at CZNIC, which is the top-level domain registry in Czech Republic, and they are responsible for the .gz top-level domain in Europe. And as part of their work, they reinvest some of the money they collect from selling domain names into producing high-quality open source DNS software. The KNOT DNS server is free software. It's released under the GPL version 3 license, meaning that the full source code is available and it's there for everyone to look into it and use it. So KNOT DNS is very feature complete. It is an authoritative master and slave zone server. So it is there for zone files, to serve zone files to the world that are your zone files, that are your zone data. It supports full zone transfers, which is called AXFR in the DNS language, and also the incremental zone transfer, the IXFRs, where only the differences since the last one zone transfer are transferred. It supports DNS X signing, including the NSEC3 signing, and it supports eDNS 0, allowing for large responses which are required for DNSSEC. There's response rate limiting. I will cover that later in the webinar in a little bit more detail. We have dynamic updates, so it's possible to change the DNS zone data through the DNS protocol itself by sending RC-compliant dynamic update packages. It supports DNS tab, which is the way to get data, performance data, and state data out of a DNS server without impacting the performance too much. I also cover that later on in this webinar. Of course, supports IPv6 together with the old legacy IPv4, and it is dynamic. It supports dynamic zone loading and reconfiguration, and very important, it scales well on modern multi-core hardware. When KNOT DNS was designed, multi-core hardware was already common, so the developers, they already designed the software in a way that it scales almost linear with more CPU power and more memory. This time in this webinar, I don't want to give you too much slides, more a hands-on approach. I have over here an installation of the KNOT DNS server, and the operating system here is Ubuntu 14.04, the long-time support version of Ubuntu, and I've installed the KNOT DNS server on this machine. What I want to show you now is how to create a new domain, a new zone file, put that into the KNOT DNS server, so you see the steps to configure the KNOT DNS server, and also then I would like to show you how to DNS sign that zone. So the zone that I want to create is called webinar.example, and I start off by creating the zone file, and KNOT supports the standard zone file format, which is standardized by RFC 1035. So the same format that we have with other name servers, like the Bind name server or the Microsoft name server, NSD or Power DNS, they all support the same format. So let me quickly type in the zone file, the SOA record, start of authority record here. Two name servers, both running KNOT DNS. The secondary I will show you in a moment is running on FreeBSD, the DNS2 example.com. And to have some meat here, an A record to see that it is signing something. So this is a very basic zone file for a zone called webinar.example. We have a time to live of 1 hour. The origin is set. Setting the origin is not mandatory. It is also read from the config file, but it's good practice to also copy the origin, the start origin, into the zone file, so it's more clear for any administrator that reads this zone file. We have 2 NS records here and 1 A record. Saving this file. And now I have a zone file. It's in etc KNOT zones webinar.example. And now I want to configure this zone file into the name server itself. The configuration file is called knot.conf, lives in etc KNOT, and this is the format. It looks very similar to a bind configuration file with all the curly braces. But there is subtle differences here. So if you come from a bind world and you want to manage a KNOT DNS server, there are some pitfalls. For example, in KNOT, the statements that have curly braces, then the curly braces are not terminated by semicolons, which they are in bind, but not here. So if you come from bind, sometimes it goes wrong. But I will show you there is a checking tool with KNOT that helps you check the configuration before applying that to the running name server. So the configuration that we have here starts by defining the IPv4 and IPv6 interfaces that our name server wants to listen on. We can have multiple of these interface definitions. For example, if we have multiple network cards in our name server. The next block is the keys block, and that defines TSIG keys for securing dynamic updates or for securing the zone transfers. There's one key called sec1 TSIG, which is for securing the zone transfer with our secondary. There's another one called local that is used for dynamic updates. Then we have a block called the remotes, and the remotes defines remote machines that can later be used in an access control list. Here we have defined a remote machine called secondary 1, which is on the address 194, and it uses all communication with that machine uses the key sec1 TSIG. So the remote definition is very similar to the server definition in a bind name server. Then we have the system block, which is global configuration for the whole name server. You can compare that to the option block in a bind name server. So the user, that is the user ID, the user account the KNOT name server will run on. So KNOT needs to start as a root to open port 53, but after doing that, it will give up all unnecessary capabilities and just run as a normal user account. Identity and version are the strings that are returned by asking for version.bind and hostname.bind. And max UDP payload is setting the EDNS 0 buffers, the maximum allowed UDP answer and this is now here set to 1280 to be safe with IPv6 UDP fragmentation. The maximum UDP payload and the default is 4K. A logging configuration here, a very simple one. The logging configuration is also very similar to bind. We have channels that define where to log. We can log to a file, and we can log to standard out, standard error, or the syslog. And inside one channel, we can define which categories we want to log. Here we log the categories any, zone, and server, any from the severity error and up, and zone and server from severity info and up. And now the main purpose of a DNS server is serving zones. And in the zone block, we define the storage, which is the directory where all the zone files will live in. And there's a DNS X key dir, which is relative to the storage. So the storage is at circnot, and so the DNS X key dir is at circnot keys. And in the DNS X key dir, we will have the DNS X key material, both the private keys and the public keys. And there's one zone definition already for example.com. And I will create a new one for webinar.example, and I will explain the configuration options while I type them in. So it starts with the file statements, and the file statement that defines the file which contains the zone information. All the statements are terminated with a semicolon, very much like in bind. Unlike in bind, we have to define the zone transfer outgoing. So by default, zone transfer is not allowed. We have to explicitly configure outgoing zone transfer, and we also have to explicitly configure the outgoing notifies. So here I'm defining that the slave server secondary 1 should be able to do an outgoing zone transfer, to request an outgoing zone transfer, and also notify packages should be sent to secondary 1 whenever the zone changes. Semantics check on enables extra checking on the zone file data. For example, that will check that there is no CNAME and other data errors, and for that CNAMEs are not used on the right hand side of MX records and NS records, such like that. These checks are optional. They are by default off, but it's more safer to set them on to catch typos and misconfiguration in zone files early on. IXFR from differences is the very same as in bind, meaning that with static zone files, the KNOT name server will create a database of all the differences between versions of the zone file, so it can then serve an incremental zone transfer when requested. That lowers the amount of data transferred with the zone transfer and also speeds up the zone transfers. For now, I don't enable DNS X, but I specify already a serial policy. Serial policy means how should the serial number, the source serial number, be incremented. And a nice feature of the KNOT DNS server is that it can automatically increment the source serial number for us. So when we edit a zone file, we don't necessarily need to increment the source serial number ourselves. If we don't do it, the KNOT DNS server will do that for us when it loads the zone. And closing curly brace for closing this zone block. So now the new zone webinar.example is configured. And I'm saving this configuration and leaving my editor. And now I want to first check whether the zone file is correct. For that, KNOT has an extra command with the KNOT client. The KNOT client is the client component, very much like RNDC and bind, that talks to the server and can request certain services, like checking the zone file and checking the configuration file. So first I check the zone with check zone and then the name of the zone. And here we see that I have made a mistake. There's a typo in the configuration file and it fails to continue in line 45. Let me quickly fix that one. So it's semantic check, not semantics check. Fix that and doing the check zone again. Still an error. Let me see what's still wrong. Let me copy semantic checks. The S was on the wrong position. So now it's good. It tells me that webinar.example, the zone loader has loaded the zone, tested the zone with a semantic check, and everything is good. The zone has not been loaded in the name server at this moment. It has just checked the zone file, whether it would be loaded. Next step is to check the configuration with KNOT C check conf. And it tells me that the configuration is valid. And now I can reload my name server. That is KNOT C reload, and it's reloading the name server. On the right side of my terminal, you see the syslog of this machine, and there we see the log information coming on. So it has reloaded the configuration, and there's one line telling us that webinar.example, the zone will be loaded with serial number 0. And there's another zone already there, example.com, which is already DNS X signed, so it's testing whether it requires a re-signing, and it found that there's no re-signing required at this moment, so the next signing event is later today. So that was the configuring the master zone. For testing the master zone, KNOT comes with its own copy of the dig command called kdig. Kdig works exactly the same way as the dig command in bind works. I'm sending a query towards the IP address of my name server asking for webinar.example SOA record, and see if we get an answer. That takes too long, actually. I have some problems here. Something strange going on. I don't see KNOT listening. Let me restart the server. It's not started, actually. Oh, but the demo gods are not nice for me today. Let me quickly check what's going wrong here. So it refuses to start. So there's something actually wrong with the with some configuration here. Yes. That looks better. So again, KNOT C status. Now it's running okay. So there was some stuff left from an early test this morning that somehow made it confused it. So again, we start with kdig, and I'm now requesting with the kdig command the SOA record of my zone from my local running name server, and it's now running, and I get the SOA record back. Next step would be to configure the slave configuration, the slave zone for that. So I'm going here to the side of this secondary, and looking there at the configuration file. And this is a very similar configuration file, just on the slave side. And for the slave side, I'm configuring same zone, this time by just configuring that this one has an xfer in, that is an incoming zone transfer. It makes it a slave zone. So there's no type slave, type master in a KNOT DNS server configuration. And I also need to configure the incoming notify, because if incoming notify is not configured, the KNOT name server will just refuse any notifies coming to the name server that is not configured to be received. So I'm saving this. Checking the configuration, and I still made a mistake. Syntax error in xfer in. There's a semicolon missing after file. Fixing that, and now the configuration is valid. And I'm doing a reload. And it loaded the file. It seems to be there was already an old file on the disk, so it loaded serial number 4. Let me quickly remove that old file. Doing a new reload, and now the zone is empty. Now going back to my master, doing a reload here should trigger the notify and then the zone transfer. And now I have a master and slave setup, and now I want to do a DNS X signing on this zone. For DNS X signing, I need to first create DNS X keys. The KNOT name server as today doesn't come with the tools to create keys, so I need to use either the tools from LDNS, from NSD, or I use the tools from Bind, which I do use here. So I'm using DNS X keygen, creating a RSA SHA-256 key, 2048-bit. I want to have the key to be created in the directory keys, and it is a zone key, which is the key for zone signing and for the domain webinar.example. So it has created the key in the key directory. This was the zone signing key, the so-called ZSK, and I also need a key signing key, a KSK. The KSK is slightly larger, 2560 bit, and it needs to have the KSK flag with minus the FKSK. So both keys are now created in the directory. Because I have created them as the user root, the KNOT DNS server wouldn't be able to load them because the name server is running as the user KNOT. So I have to change the permissions on the files. So I'm changing everything in the keys directory to be owned by the user KNOT. And the last step to do is to enable DNS X signing in the configuration. So I'm opening the knot-conf configuration file, go to my webinar example zone, and do a DNSSEC enable on here. Save. knot-c check conf to check the configuration. It's valid. knot-c reload will reload everything. And now we see here on the right hand side, it tells us that the webinar example DNSSEC is fully signed and sends outgoing notifies to my slave, which is on 194. And then we see that there is an incoming zone transfer coming in from my secondary, and it doesn't have an history for this because it was the first time the zone was actually transferred. So it's doing an IXFR and full zone transfer. We see the IXFR going out, and if we switch over to the secondary, we see here in the log files that there was an incoming AXFR from 212, which is my master. And the zone file has been updated from serial 4 to serial number in Unix timestamp style. And now I have a signed zone. If I do the kdic command again, kdic, let me type it in, kdic at 127.0.2.1.2.1.2, asking for the SOA record of webinar.example, and this time I ask with plus DNSSEC, and it shows me the signatures. So I have a valid signed zone because I've seen the SOA record here and a signature for the SOA record. Changing now the zone file is easy. I go into the zone file, and it already has changed on disk. We now see the signed version. And what's nice about KNOT is that it doesn't mix the signatures and the NSEC records with the normal data. Instead, it writes all the DNSSEC data at the end of the file. So I have my plain text DNS data here on the top, which I can edit, and I have the DNSSEC signatures and the NSEC chain at the bottom, and I don't need to mess around with that. So I'm creating now a new entry. TXT record, hello webinar. I don't increment the serial number here. I just put in a new TXT record, saving that file and doing a knot-c check zone. And here I get some warnings because it detects that the webinar.example has a new record which doesn't have any signatures. So it tells me there's no RSIG record for type TXT, which is okay because I just created the text record but no signatures for it. The signatures need to be created by the DNS server itself, and that will be done on the reload. But there's no other error. There's just warnings, and the warnings just tell me that the name server will create these records, the signatures and the NSEC records. knot-c reload webinar.example now reloads the zone file. It automatically changes the source serial number. We see that on the right-hand side, zone file updated, serial number has changed from this Unix timestamp to that Unix timestamp, and it sends a notify, and we see the outgoing zone transfer. And when I now do the dig and I ask for a TXT record of hello webinar example, we see that we get the data. It's in there, it was served by the name server, and it is signed, it has a signature. And that was the quick demo of how to create master and slave zones in the KNOT name server, and how to sign a zone. So back to my slides. There's another nice feature that is not available in any, or to my knowledge, not available in any other name server, open source name server in the market. That is the ability to synthesize records on the fly, which is especially interesting for IPv6 reverse zones. Now, IPv6 reverse zones, traditionally, providers have pre-populated these reverse entries in IPv4 with standard names. In IPv6, that's not possible anymore because the /64 prefix is just too large. It has too many IP addresses to create a pointer record for every possible IPv6 address in a /64 network. KNOT, we can define with a so-called query module that it synthesizes an answer from a definition of a reverse zone automatically. So here is the definition. We want KNOT to synthesize a record for a reverse zone. So it's for reverse. The name should start, the host name should start with IPv6 ref dash. We can use any kind of host name prefix here. The second level and top level domain of the creator records is example.com. Time to live is 3,600 seconds, and it's for the 2001 DB8 network. And I have this configuration, this synthesized configuration in my name server here, and I can quickly show you how it works. If I now use dig or kdig, asking with -x, -x is asking for the pointer record of an IPv4 or IPv6 address. And I'm typing in 2001 DB8 : 100:1, and I'm asking that towards my KNOT name server. I'm getting an answer, and the answer contains the reversed IPv6 address, ip6.arpa, my time to live, pointer record, and then a host name which has been synthesized from the information in the query module. Currently, there are some limitations of these synthesizers. The synthesizers of records doesn't work with DNS X, but the team is working on that, and they might offer on-the-fly signing with some later version of the KNOT name server. Also, support in KNOT is for DNS Tab, and DNS Tab is a new standards interface to read internal status information from a DNS server. You can think of DNS Tab as being the same or very similar to the query logging in bind, but without the drawbacks. If you enable query logging on a name server, like on a bind name server, it severely impacts the performance of the name server. Usually we see 1/3 of the performance dropping by enabling query logging. With DNS Tab, it's possible to get this query log information and much more from a running name server without impacting the performance too much. DNS Tab is actually a larger topic that I would like to cover in a dedicated webinar later in this year, because there are also other name servers now available that offer DNS Tab information. I also would like to present you some tools that exist for visualizing and filtering of the DNS Tab information. KNOT also supports response rate limiting. We have covered response rate limiting and the reason for response rate limiting, namely the DNS reflection attacks in the previous webinar. Of the dangers of DNS reflection attacks, I have the link here in the list, and KNOT supports these rate limiting to mitigate reflection attacks. Basically, we can configure KNOT to only answer a certain amount of queries per second from the same IP address to stop someone hitting the name server with a high number of queries and redirecting that to a victim. KNOT, apart from the KNOT D server process, comes with some tools. There's KNOT C, I've shown you that, which is the command tool to control the server process and doing some checking of the configuration files and the zone files. There's KDIG, which is a clone of the dig command. There's also khost, being a clone of the host command, KNSUpdate, which is a clone of the NSUpdate command, and KNSEC3 hash, it's a clone of the NSEC3 hash command from ISC-bind to calculate out of a domain name an NSEC3 hashed name, which is required if you want to do some troubleshooting on NSEC3 hashed DNS X zones. So the only step that is missing from the tools part is the DNSSEC key creation part, for which we currently need to use the bind tools or the LDNS tools. But I will tell you a little bit later that is about to change. One really nice feature of KNOT is its speed. And here we see a benchmark that is published by the people from GZNIC, comparing bind 910, KNOT, NSD, Power DNS, and the Microsoft DNS server, and for a situation, a hosting situation with 10,000 zones. And we see that both KNOT, NSD, and Power DNS scale very well in this situation, and bind and Microsoft DNS not so well in this situation. This also tells us that for situations less than 10,000 zones and less than 100,000 queries per second, it's not really worthwhile to do any performance tuning because all name servers on modern hardware will just scale very well. And the picture is even more different if we look at the scenario with 1 million zones hosting. And here we see the dark blue line on the top. That is the latest KNOT 161, which scales from the best from all the name servers in the test. The next best was NSD 4, which is the or NSD 3, which is the light green and the dark green ones. Then there is bind, the purple one, and Power DNS being not so fast in this situation. And about the startup time and memory usage here, KNOT also is not the best, but quite good in this respect. You see here KNOT 1.5, which is I'm using 1.6.2 here, but it's comparable. Startup time was 95 seconds with 100,000 zones, and memory consumption a little bit below 1 gigabyte. And this comparison sees that the developers of KNOT have achieved quite a reduction of memory usage. The 1.4 version that was there last year used 3 gigabyte on the same scenario, and it's now down to 1 gigabyte. And it's almost the best. Just NSD and Power DNS are better in this respect in memory consumption. But yeah, memory is cheap nowadays. So where can I use KNOT? It's available from source, GPL licensed on this URL, and there are ready-made packages and installation receipts for Debian, Ubuntu, Fedora, OpenSUSE, Arch Linux, Gentoo, the BSDs, and Mac OS X. And it's probably possible to compile on all Unix flavored operating systems, Solaris, HPUX, AX. The team around CZNIC is working on version 2, and the major change of version 2 of KNOT is it's an implementation of a key and signing policy, which will automate the DNS X key rollover. And this would be then the first open source authoritative name server that implements key and signing policy and automated key rollover in the product itself. With NSD and Power DNS bind, there's always the need to have some other product, mostly OpenDNSSEC today, to have an automated key rollovers. Having that integrated in the authoritative server is a big step and will ease the maintenance and operation of the authoritative name server with DNSSEC signed zones. Also, they have ripped out OpenSSL and replaced it with GNU TLS Nettle. And there's already a preview available since February this year. So if you want to play around, there's KNOT 1.99.x, and there's a link to the mailing list where they announce the new version and give links to the source repository where you can download and test out the source code. So this concludes my webinar. We will have a question and answer section, but before we go in question and answer section, I would like to give you some heads up on our next webinar, which will be the report from IETF 92 in Dallas, which is next week, March 22nd to 27th, and we plan to talk about new developments in DHCP and DNS and IPv6. Especially, I would like to highlight the new standards for storing PGP keys and securing S/MIME certificates by using DNS X, namely the S/MIME A record and the OpenPGP record. Even though these standards have not been finalized and are not RFC at this moment, but they are working group last call, we already see first email providers implementing that, and there's a big drive against that, and it will be a huge game changer in the email security market by implementing these key distribution mechanisms and certification checking mechanisms using DNS X. So stay tuned. The webinar is on Tuesday, March 31st, in 2 weeks from now, on 4 p.m. Central Europe time, or 2 p.m. GMT. So, and now for some question and answers.
Yes, Carson, we've gotten a few questions in here. First off, does not support multi-mastering?
It's hard to answer. It is possible to install KNOT in a multi-master environment. Multi-master meaning that there is more than one master server. However, then the replication of the data needs to be done outside the KNOT name server, maybe by some zone transfer, not zone transfer, by copying with secure copy or rsync or other mechanisms. So there's no extra support for it. It is possible to run KNOT in a multi-master scenario, but there's no extra support for it. Let's take it that way.
All right, thank you. And next question is the last value on your SOA record the default TTL or the negative cache TTL?
It's now the negative cache TTL. The semantics of the SOA record was changed in around 1998. I don't have the RFC number in my head, but before 1998, before a specific RFC that has been published at that point of time, it was the default TTL. Today, it's the negative cache TTL, and it's used as that. And if you want to set the default TTL, the $TTL control statement is used for that, and KNOT supports that. So it's the same as in bind.
Right, and a reminder, if anybody does have questions, please feel free to type them out completely in the chat window. Another question, what is the limit on the number of domain names resolved, if there is?
I'm not aware of any number of any limit on the number of domain names there. I mean, it's possibly just memory in the server, how much data and domain names you can load into the server, if that is the question.
All right, looks like those are the questions that we had submitted right now. As a reminder to everybody, this webinar has been recorded and it will be posted online. And as soon as it has been, we will be sending links to that to all the attendees. So
Okay,
let me see, we might have one more question. Hold on. Somebody submitted, there's a question on OMs. How do you find the queries per second rate?
Yeah, that is not an easy answer to question to answer. Testing authoritative or caching name servers is quite an art, and I would say it's not possible to do it right. You can just do it less wrong, and we might do an extra webinar on that topic, how to do performance testing of DNS servers. I have or we at Men&Mice, we have tools for doing that, and also the people from the KNOT name server have their tools to do that. And basically what you need to do is you need to have load generators, special programs that create DNS traffic. I today use a special version of the QueryPerf++ tool, which have been developed together with the Bind 10, now Bundy name server. It was created and programmed by Jinmei Tayuta, and you find the sources on GitHub for that. And that tool can be configured to send as many UDP or TCP queries towards a name server, and it then records back how many answers are coming back and prints out the maximum query per second rate. In order to test this, there are some important configuration things that you need to do in a testing environment. For example, you need to have always more a load generator and more powerful load generator machines than the name server that you test, and also you need high quality switches, high quality routers, high quality network cards, and high quality servers to do that testing. So just having, for example, one not so good network card in one of the machines, you are basically testing that network card and not the maximum performance of the name server, because the name servers nowadays, like KNOT, like NSD, they all operate so fast, it's almost near line speed, and it's very easy to do it wrong and test the wrong end.
Can you please repeat the name of that program, that analyzer that you had mentioned?
QueryPerf++.
All right, thank you.
I'll probably do some show notes, and we will publish that together with the slides and the video. And it will be there, the link.
Thank you. And we did get a bit of a philosophical question. Why not bring new features to ISC to make Bind better instead of coming up with an entirely new DNS solution?
I cannot answer that. You have to ask the people at NixCZ for that. Probably one reason is it's good to have diversity in the name server field. If there's a monoculture of just having one product in the market, if that one product then has a severe security problem, all machines are affected, and maybe the whole internet is affected. So having multiple good authoritative and also caching name servers available in open source is a good thing. And yes, people also work on Bind, and Bind also evolves every time and gets better.
Excellent. Are there any more questions? It looks like we've answered all the ones we've got. So again, this has been recorded, and we will be submitting a link as soon as the webinar is posted. Do you have anything further to add, Carson, before we close?
No, I'm fine. Thank you for listening, and see you next time or hear you next time on the next webinar, ITF 92.
Thank you all for your time.
Thank you, Paul.
Thank you, sir.
Have a good day.